Hey all, this is Derek in section 9.3, graphing quadratic equations. And the graph of a quadratic is called a parabola. And we'll start with finding x and y intercepts on the parabola, and then we'll learn to find the vertex, which is this point right down here at the bottom, or it could also be the top, it's the higher low point. And we'll put those together for drawing the graph at the end. So, just like when we did equations of lines, to find the x-intercept we let y equal 0, and to find the y-intercept we let x equal 0. Exact same thing regardless of whether or not it's what kind of equation it is. That will hold true for the rest of math. So we'll do that same thing here, but now we're going to encounter, when we were doing this with lines, we got to solve a linear equation, and now we'll have to solve a quadratic, which is what this chapter is about, is solving quadratics. I think that was all I wanted to show there. So, first up we have find the intercepts of the parabola whose function is given, enter D and E if there are no intercepts. So, let me go back to here for a second. You're always going to have a y-intercept, but it's possible for a parabola to be opening upwards and be above the x-axis, and so it wouldn't have x-intercepts. Likewise, it could be opening downwards and already below the x-axis, depending on what the translation is. So those are cases where it would be a D and E. It's also possible, normally we're going to get 2, right? Because that's kind of the usual thing. But if this is just perfect, it could come down, it could bounce off the axis and come back up. And we could have a situation where we only have 1 intercept as well for x. So for y, we're always going to have 1 intercept. For x, we're either going to have none, 1, or 2. It just sort of depends on the geometry. Okay, so that was the D and E part. And then for this, we're just going to let the y equal 0, which is f of x in this case. And then we're going to factor and find the x-intercepts. So 0 equals x is in front. What multiplies to -9 and adds to be -8 would be a -9 and a +1. So I would have x-intercepts at 9 and -1. And I think the answer entry on this, it maybe has a box, and I think it's this instead of ordered pairs this time, but double check that as you're entering. I think it's in the directions. This next one, oops, I should still find the y-intercept, my bad. So the y-intercept is actually super easy. If this isn't factored, when you let x equal 0, and I'm going to call this y instead f of x, here's what will happen every time, is those zeros are going to knock out those first 2 terms, and then you're left with the number on the end. So the same way in y equals mx plus b, that number on the end was the y-intercept. In this case, the c is going to be the y-intercept if this is ax squared plus bx plus c. So for this one, we got, right now it's this. And that's hard to factor because there's lots of negative signs. So since I'm solving, if I was just factoring it, I would have to factor out the -1. But since I'm solving it and I have both sides, it's an equation, I have 2 sides, I'm not just rearranging and not rewriting this side, I'm actually solving it out, and I have a 0 over here. That lets me multiply both sides by -1, and then I can go 0 equals x squared plus 10x plus 25, and that's just easier numbers to work with. So multiplying both sides by -1 is handy. Here we're going to get x plus 5 quantity squared, and I could also write that x plus 5 x plus 5, but what you'll see is that's the case where we just have that 1 x-intercept. So this would be coming down, actually it would be coming up, touching -5 and coming back down. And then for the y-intercept, again, that's that number on the end. So if I let those x's be 0, I'm left with -25. So my y-intercept is -25. Okay, so next up we're going to find the vertex of the parabola. And so the vertex was this part where the parabola has basically what's called a turning point, where it changes directions. And it could be opening up in this case and have a minimum value, or it could be opening down and have a maximum value, so a low point or a high point. And what determines that is if it's a positive x squared, it opens up. If it is a negative x squared, it opens down. And to find the coordinates of the vertex, what we do is we solve this little negative b over 2a deal. And so this is for a parabola in the form ax squared plus bx plus c. If you happen to remember the quadratic formula from maybe a high school class, which is our next section, by the way, when we solve the quadratic, we identify the coefficients by a, b, and c. And that's the same case in this. This is actually the first part of the quadratic formula that we'll see in the next section. So looking at this is y equals 1x squared minus 6x plus 8. So a in this case is the 1 in front of the x squared. B is negative 6. C that I don't care about for this application would be 8. I just need B and A for finding the vertex. And then what we do is we just plug into the formula. So x equals negative B, so negative of negative 6 over 2 times A. And that would be negative 6 is 6 over 2, so that should be 3. And then to find the y coordinate, this just says evaluate f at what we just found, which is basically a fancy way of saying plug the 3 in and then get y that goes with it. So we're finding f of 3. So 3 squared minus 6 times 3 plus 8. That would be 9, and 8 is 17 minus 18, so I think that's negative 1. So my vertex would be at x was 3 and y was negative 1. Same thing here. So x equals negative b over 2a, so that'd be negative 2 over 2 times negative 1. So double negative would make that positive 2 over 2 or 1. And then we just evaluate at 1. So negative of 1 squared. Notice that's not negative 1 squared. It's going to be 1 squared and then take the negative. Plus 2 times 1 plus 5. So it's 7, and then minus 1 should be 6. So vertex is at 1, 6. Okay, and then for this last set of problems, we put those two ideas together, and we're given a function. We're going to find the x and y intercepts and the vertex, and then we'll use that information to graph the function. So starting with the x-intercept, I'm going to say 0 equals x squared minus 6x. I'm going to factor an x out, x minus 6. So here I have x equals 0. Here I have x equals 6. And then for my y-intercept, in this case, so if I let x equals 0, y is 0. So my y-intercept is 0, 0, which I had already found over here. And this one would be 0, 0. This one is 6, 0, just to be clear. And then let's find a vertex. So vertex x is going to be negative b, so negative of negative 6 over 2a, so 2 times 1. So negative 6 is 6 over 2 makes 3, and then tossing the 3 in there, finding f of 3, I get 3 squared minus 6 times 3. So that would be 9 minus 18, or negative 9. So my vertex is at x was 3 and y was negative 9. So then to graph this in the computer, what you'll do is you'll start with the vertex 3, negative 9, and then you'll just graph one of these other points that we got. So if you click right here on 0, 0, it will draw the parabola in for the rest. And so you should get something that looks about like that, roughly. Okay, same directions. So x-intercepts, we'd have 0 equals 100 minus x squared. So I could solve this two different ways. I could factor plus x, that's a difference of squares, so I'm just doing my a plus b and my a minus b. And I have x equals negative 10 or x equals 10. I could have also brought the x squared over and did this the same way we did 9-1, where we then take the root of both sides, don't forget the plus minus, and then we get the exact same plus or minus 10 that I got by factoring. So that's going to be my x-intercept, so those are going to be on the 10s. And then my y-intercept, if I let x equals 0, then y is 100. So that would be my y-intercept. And then on this one, I kind of like, that's nice because that's also my vertex. You could just sort of see that from the symmetry of where these points are coming out. Just to kind of show that in terms of negative b over 2a, it would be, x equals negative b, but in this case, there is no b term. So what that means is it's like plus 0x minus x squared. So that's 0 over 2 times negative 1. And there's that x equals 0 for the x coordinate of my vertex. Toss that back in, and then you're finding the 100 again. Okay, so same directions here, so I'll find my x-intercept. So 0 equals negative 2x squared plus 12x minus 10. I could factor a negative 2 out front. I could also divide everything by negative 2 if that seemed easier to me, which it did, so I did that. So this would be x squared. That would flip that to a negative 6x, and then double negative there would make plus 5. And again, if you factor that out, you would just have the same thing with the negative 2 in front. Since I'm solving, it lets me just make the 2 disappear, and it seems easier. So now that's a lot easier to factor. And let's see, it would be minus 1 and x minus 5 would multiply to be positive 5, add to be negative 6. So I'm going to have x-intercepts at x is 1 and x is 5. My y-intercept, for that, I got to be careful and go back to the original equation. So if I let x is equals 0, then that leaves me y as a negative 10. So 0, negative 10 for the y-intercept. And then the vertex, so that's going to be x equals negative b. So negative, and then again, also go back to the original. Dividing this negative 2 out was fine when I had this equal to 0, not fine when I have it equal to f of x. So coming back here, negative b over 2a, so negative 12 over 2 times negative 2. So that's 12 over 4, the double negative, so it's positive. So that would make 3. I can plug that back in and find f of 3. So negative 2 and then times 3 squared plus 12 times 3 and minus 10. So that's going to be 918 plus 36 minus 10. So that is negative 28 plus 36, which is a difference of 8, and that would be positive. So my vertex is going to be at 3, 8. So once I got that, now I can just come over and plot that point. So 3, 8 would be right there. And then I could just plot any of these, 3, 8, I just plot 3, negative 8, sorry about that, 3, 8. And then I could plot the y-intercept way down here, or I could plot one of those x-intercepts. Any of those points would then have the computer draw the rest of the parabola.